In this video, let us understand what recruiters look for when they are hiring for design engineering roles. So design engineering roles are of course very important, very critical to the overall product development success of a product. So if there is a product development project, the first thing which recruiters will look for is to hire the design engineers who will convert the idea from concept to production. So then what do recruiters want? So the most common term which is thrown about in terms of hiring is return on investment. So if I'm hiring a person, what is the return on investment I will be getting? If I'm investing certain amount of salary or compensation for the engineer whom I'm hiring, what are the returns I will be getting, let's say after a year or two? So that is the main thing when recruiters are recruiting for any role, irrespective of whether it's design engineering or whether it's non-engineering. So the delivery in projects and how much that hire adds value to the projects, or how much that candidate will add value to the overall product development process, that is validated by the recruiters, and then they go out and recruit the people required for that job. So the person who is giving a high return on investment, or who is predicted to give a high return on investment, will be most suitable for a certain role. So basically recruiters have a list of requirements which are developed based on the design engineering role, which has to be performed as part of the product development process. So we have studied what is the role of design engineering in product development process. So from that, the list of requirements for a possible recruit are developed, and that is used by the recruiters to go out and recruit the people for the project. So irrespective of whether it's an engineering role or non-engineering role, all professional roles require some professional skills. For example, communication, ability to work in a team, attitude, etc. So these are very fundamental skills which are required in any recruit, irrespective of engineering or non-engineering domain. They have to be good communicators, they have to be having the ability to work in a team, and they should have a good positive working attitude towards the projects. Now going into specifics of design engineering is a high responsibility and high impact profession, because the work a design engineering does has a huge downstream impact on the work of the others who are working after the design work has been completed. So based on the design, the manufacturing process and the whole infrastructure will get set up. So if there is any defect or any fault in the designs, all of these things have to be changed, and there is a huge cost impact once the designs are released for production. Hence it's a high responsibility and a high impact profession. Also, that means that in recruitment, we cannot expect an entrant or a recruit who is just out of college and who doesn't have much experience in designing of systems to actually start designing systems and give that much amount of responsibility once they have entered into the workforce. So that is one thing to consider in recruitment. So then that means that there are two levels at which recruitment happens in design engineering. One is entry level. An example is a graduate engineering trainee, and then there is the experienced levels, and the expectations are different for both the levels. At the entry level, the candidates are expected to have an engineering mind, to be problem solvers, to have good engineering basics, the basics which they learned during the engineering programs, to have exposure to engineering tools like, for example, CAD and mathematical modeling tools, basic exposure to practical problem solving, for example, working on actual projects like Baha, Formula and all of that. That is a really helpful way of developing practical problem solving skills, and also be able to learn and pick up things as they go along, because the first year once they enter out of college is always a highly learning intensive phase in which they learn about the process, the product development process, how the work happens, and what kind of skills and knowledge are required to be developed to deliver for the projects. So at entry level, the expectations are generally very low, or as you can see over here. But as the design engineers get experience and they move along the careers, the expectations are much higher, as you can see. So the experienced level design engineers are required to have the ability to develop or deliver in the project through the skills and knowledge they have gained through the experience, then take responsibility and take design decisions in specific domains, then see the design through the product development process, and very importantly, solve the issues which are coming up. Solving issues is a huge task. Like for example, if you're designing the chassis brackets of a vehicle and the vehicle goes in for testing, and during testing, It is found that one of the chassis bracket has failed, it has broken. So the design engineer has to go and investigate what is the cause of failure, what is the root cause, and find out how to basically rectify the issue in the design. So that requires good amount of effort and good amounts of experience, a prior experience in the product development. Then innovation may be expected. So at experience level, as you accumulate knowledge, you can also innovate better because you know better as to what things work and which things do not work in the design. So you are in a better position to innovate and develop new ideas and develop new ways of solving problems. And finally, improving designs for cost, weight, and other parameters which add more value to the company in terms of cost savings and other savings, etc. So engineers who come out of college are undergoing the transition from being engineering literate to being engineering practitioners. So when we are in college, we learn about math, physics, chemistry, the basics of engineering, how they are applied in problems and the concepts and how to solve basic engineering problems. Then in engineering practice, we need to learn how to apply those basics to solve the real problems, how to develop products, how to develop systems, how to improve those systems, and also when there are issues, how to troubleshoot on those systems. So as an engineering practitioner, all of these skills are required, which are more advanced skills as compared to the skills we learn in college. So how to make this transition from being an engineering literate to being engineering practitioner? So we need to work on projects, assignments to develop these skills. So these skills cannot be developed in a classroom or through a textbook. We need to actually work on projects, work on solving real problems, and these skills and knowledge get developed through that. So these include learning the skills to solve the problems practically, learning the skills of product development. So when we are in the product development process, only then we understand the nuances of the product development and we are able to meld into the product development process as a design engineer. And also learning engineering design as a whole and learning the tools like, for example, CAD. If you're not learned it already, then you might learn it in the company or organization while working on the projects. Now let's go through a list of most fundamental skills required for excellence in design engineering. So this is a list of skills which I have prepared based on my experience and learning and whatever I have understood which is required from a design engineering profession in terms of attitude, mindsets, and the approach in working. So I have categorized in two ways. One is behavioral and another one is technical. Behavioral skills are generic skills which are required for problem solving like critical thinking, analytical thinking. So these are very fundamental skills required to break down a complex problem into its individual elements and then solve the problem. Critical thinking and analytical thinking are very basic in that. Then when we are solving based on analysis, if we are getting stuck, then we need to think out of the box. That's where creative problem solving comes into play. So these two, the first two, critical thinking and creative problem solving, are very central to engineering problem solving for design engineers. Next, curiosity and learning. So design engineering profession requires us to learn continuously. The more we learn, the more knowledge we gather, the more experience we gather, the better we can design. So that's a fact. And then there is attention to detail. Of course, when we are designing components and systems which are having a lot of thousands of details, we need to go through each and every detail, because if there is any defect in the design, once it goes into production, then that will incur heavy cost. So attention to detail is also a very key behavioral attribute for design engineers. And finally, it is clarity in communication. Design and engineering requires good amount of communication within teams and clarity in communication in basically representing ideas and explaining the concepts. That is very important for design engineers. In terms of technical skills, the first important skill, the most important skill I would consider is the concept development, idea generation in product design. So as we have seen, the concept design phase is the phase in which the concepts are developed. So it's the creative phase. So if a design engineer is able to develop multiple different concepts and analyze them and select them for a problem which is being solved for a product, then that's a very, very important skill. And that is a very high value skill, a very sought after skill. So concept development is a very highly sought after skill in the industry because it creates new value. That's the basis of innovation. Next, visualization and documentation, CAD, engineering drawings preparation and all of that. So that comes under the visualization and documentation. These are very essential because today all of the systems are being managed in the digital formats in CAD, in PLM, could say product lifecycle management, and engineering drawings. So design engineers are required to know about how to visualize their designs in the digital workspace and also work on the drawings and manage the product lifecycle. So that's another important skill which is required. And then there is design for manufacturing and assembly, and in generic, design for X. Now design for manufacturing and assembly will also include the understanding of materials and manufacturing to make sure that the designs are feasible for production. So that set of skill set is a very important skill set for converting a concept to something which can be manufacturable. And then finally, it is engineering analysis. So engineering analysis is the application of the engineering basics which we study in college, like mechanics of materials, engineering mechanics, theory of machines, thermodynamics, fluid mechanics. So all of those basics, when applied to analysis of products in different scenarios. So that's what engineering analysis is. It can be at the concept level, in which we are just doing a hand calculation by using the fundamental principles, or it can be at a much more complex and more refined level at which we are basically doing simulations like FEA simulations or CFD simulations. So the design engineer should be well versed with the engineering analysis methods. Generally in an organization, there are separate departments for the analyst or CAE, as it is called, computer aided engineering department, who are specialized in the simulation of various different types like FEA, CFD, structural, vibration, etc. The design engineer should be well versed in all of those engineering analysis methods, at least at the basic level, so that it can be applied in the concept phase. And then once it goes into the detailed design phase, the design engineer can take informed decisions based on the simulation along with the simulation experts or analysts. So these are the four very important technical skills required for design engineering: concept development, visualization and documentation, design for manufacturing and assembly, and design for X, where X can be any other product requirement. For example, design for safety, design for reliability, or design for compactness of the design, design for weight, or design for cost. It can be anything. X can be anything. So the design engineer has to design for that product requirement. And finally, engineering analysis. So these four are very basic and most fundamental skills required for design engineering in any context. So if you're developing a consumer product, or if you're developing a new type of a vehicle, or if you're developing a new type of an industrial machine, or a new device or a widget, these four skills will be common for all. If you want to learn in more depth regarding the subjects in design engineering, you can refer to the courses which I am creating. So I'm creating a knowledge platform which is specially aimed for design engineers to improve their ability to innovate. So that's the mission I'm working for, and I'm doing that through self-paced online courses which are ranging from mechanical design process, material selection, manufacturing process selection, sheet metal design, GD&T basics, advanced and application, basics of tolerance stack-ups, mechanism design, project-based courses, and even automotive engineering design-based courses like vehicle dynamics, automotive product development, and etc. You can access all of my 19 courses at an offer price in one single bundle. The link to that bundle is given in the description below. I hope this video has been educational to you, and thank you for watching. Bye.